Hello, and welcome to my combo lords here. You like my hexagonal sunglasses someone gave me? Well, we do like hexagons around here, so those suit pretty well. But these are a different type of glasses than we'll mostly be talking about today, which are magnifying glasses, both as an analogy and as a scientific tool, partially just a theme for a stream with a few random mathematical and other plans. And as usual, I will add some timestamps at some point after this stream. I was a little busy on the last few, but at some point today, once this processes, I'll put in some timestamps for the chapters of what we talk about. And in addition to using magnifying glasses as a mathematical analogy, we also will possibly try and find a little bit of sunlight around here. And I'm opening my phone to get my chats up. And if we find a little sunlight, we might be able to use this for a cool old-fashioned type of use, which is you can focus the light from the sun into a small speck, and if you make this speck the right distance and tiny size, you can actually light stuff on fire with the magnifying glass. As usual, use extreme caution if you ever try anything like that yourself. Because you can get burnt, and of course you don't want to light something on fire in a dry wooded area or anywhere that is flammable. But it is interesting to know that it actually works. I have a smaller magnifying glass that I've had here for a little while in one of these boxes that I'll locate in a minute, that although now it's been through a lot, all beaten and battered, and I'm not sure how good it's going to be at conducting a flame-like thing. It is something that I have used before. When I was at a friend's cabin, we did some experiments, and it totally works. You can actually burn stuff with the magnifying glass. And that leads to a whole round of possible experiments. Like, instantly what it makes me wonder is, if I had a big campfire, could I start a campfire with a magnifying glass? What about if I had something soaked in lighter fluid? If I singed it with the magnifying glass, would it ignite the lighter fluid? And a whole other round of possible questions. And someone recently gave me this big ol' magnifying glass, so this seems like a good contender. I'm not positive if bigger is better with that trait. The smaller one was actually the one I've used before successfully. And we also have this square-like one, for whatever use that might be, this rectangular thing. But of course, first we will do some chatting about math, because we'll wait to see if it gets a little sunnier back here, or if I'm going to have to see if there's better sun in the front yard to try and experiment like that. And for the time being, I just have this graph in the background for fun. It was just one I was fiddling around with that. Let me move my face a little smaller so we could see what this graph was. One of our sine things plugged into something modular for the background. And someone asked, have I never burned your mate with one? Well, yeah, I don't think I've actually burned one of my friends with one. I guess it could be in the category of an acceptable mild prank, depending on your relationship with your friend and how small of a burn you give. But no, I haven't burnt my friends. I just burnt other things with my friends. So, looking right away, just since we're on the topic, at what Wikipedia says about magnifying glasses, they also are a reminder that these are a classic trope in detective fiction, and that's actually where my love for a magnifying glass originally came, is I've always liked a detective, clue-like, mystery-like vibe, and even as an interpretation of life, sometimes when me and my friends are hiking and come across something weird, or something that some might call a piece of trash or something, you can interpret it as a clue. And even if it's not a clue you're going to follow, it still is a fun thing to brainstorm and think about the ways that things are connected. Meaningful coincidences that things could have been led by other things or lead to other things. So I've always liked magnifying glasses just for their sort of silly relationship with detective fiction. But when I realized that they can also light stuff on fire, That made me realize they're an even bigger symbol of what's going on in combo class than I realized. Kind of like how when I was getting really into clocks, I liked them more for their surreal philosophical vibe of a stopped clock. And then as I studied more and more modular arithmetic, I found more and more applications of things I could describe as clocks. Similarly with dice, I always liked their philosophical aspect and their probability aspect. And as I learned more about the possibilities of dice and even geometric aspects of different dice-like shapes, it made me realize the dice were an extra good theme. And I think magnifying glasses, I might have to get a bunch of those for a future grade, or a magnet, like a huge one, a massive one. Um, because they seem to be a pretty suited theme for what's going on in combo class too. Not only can they burn things, but they can let you look at small things that you might have otherwise not known all the details about in more detail. And that's the main way that we're going to use today's analogy part of the magnifying glasses for, is some examples of a really simple concept that may seem like, oh, I already know what that does. But when you look a little deeper under the surface with a magnifying glass of sorts, you find out a lot more than you thought you knew. And since we're on the Wikipedia page, I also want to note that when I was reading this earlier for fun, I was curious about this See Also article. It was like burning glass. What is a burning lens or burning glass? And apparently this is something that was designed, like how a magnifying glass can burn stuff, just for that purpose. And they have this whole history that I'm going to have to study more about sometime. And maybe we'll even see in a future grade if we can build our own burning glass. We will not be using it for war, maybe more for this second use of primitive fire making. And quite interesting. So they also have one about, here's a whole nother one I hadn't gone to yet, solar furnace. A structure, we're getting bigger and bigger scale. The next See Also is going to be like planet obliterating solar ship or something. We're going up and up in scale. A solar furnace is a structure that concentrates the sun to be like a whole oven. So maybe someday in like grade -8, we are going to burn down something very safely in a massive solar oven. Someone claims here that you can light tinder, such as little flammable pieces of wood or something with the magnifying glass, but that you couldn't light a volatile fluid. But I'm wondering that if I had the tinder next to the volatile fluid, maybe I could make some combo type of reaction. We'll see. And maybe we will build a huge telescope as well. And someone said, how crazy can I be? And that they're a big fan. I can be pretty crazy. I am known by many to be one of the crazier of the average people. However, I calculate my craziness, you know? I'm still here in one piece, and I make a lot of content, so the craziness is done with some degree of precision. So, thank you all for joining me, and I will chat with the comments every little bit, but first I will go down a few little rabbit holes. And one of the rabbit holes that I'm always reminded of when I first thought of how you could zoom in to something in a magnifying-like way is the number 1 and what are known as the roots of unity, which I already made an episode about, but I have some, newer, slightly different phrasings on them here, and maybe some people didn't get the chance to see that either. And what's going on there is that when you say the number 1, we're talking about a number, a singular point on a number line. And this is covered in my percent notes from the last bonus video I dropped about how percents and percentages are somewhat unnecessary. But we'll just write it in the corner here because I just need a little room. On a number line, if that's 0, 1 is just a point. But when you introduce negative numbers, you get this other realm of mirror images of 1. And -1 is really sort of 1 in disguise, because what does negative mean? It means we went 1, but in a different direction, essentially. You can't grab a negative something in the real world. It really means a directionality of a number 1. And so, what if we wanted to extend it more ways? Well, we could potentially look at all the points that are a distance of 1 from 0. And at first that seems nonsensical, like, well, there's a number line. What are all these points out here supposed to mean? I mean, that point is 1 from 0, but what is that point? But this works if we call these the complex numbers that are partially real and partially imaginary. And we say, all right, like there I got a point that's about like some amount of square roots of real and that same amount of square roots of I. And it turns out that that point, if we say that's the one that's like at an equal angle right here on each side, that point is one of the 8th square roots, or not square roots, one of the 8th roots of 1. If you raise that to the 8th power, the way that complex multiplication or exponentiation and stuff has been defined, it kind of hops around the circle and gets back there. And I made a clock out of that. These are the 12th roots of unity, because clocks come in 12 for a reason. 12 is a good number, and then we get to include our 6th roots, our 4th roots, our 3rd roots, and our 2nd roots, and so on. And all these numbers are secretly the roots of 1. So, for a little while, I had thought 1 is a much more boring number compared to 0. 1 doesn't have as much going on for it. But 1 does have a lot hidden inside it. We could also magnify. Instead of magnifying the roots of 1, we could say, well, negatives and imaginary numbers opened up a new realm. What about fractions? Those also open a new realm. So similar to how 2 has an opposite that's -2, it also has an inverse that's 1/2. But 1, its inverse in terms of multiplication, like its reciprocal, where you flip it, 1 divided by itself, is itself. So when you zoom in on itself, you get a sort of mirror. And if you said, I'm going to keep taking the reciprocal of something, most numbers have a two-way flip. But that one just stays on itself. And what does that tell you about the number 1? Well, if you dig deeper, you'll see how this relates to 1 being the multiplicative identity, the one that doesn't change elements under multiplication. And you start to get to a lot of the heart of how 1 is, along with 0, the other underlying fundamental thing underpinning our number line, or our number plane, if we're talking about the complex numbers. Because 1, like 0, is the multiplicative identity, and the element that eats everything under multiplication, turns everything to the 0. 1 is the one that keeps everything the same under multiplication and goes to a successor of something, the next natural number, for example, when you add it. So 1 has a lot of secret powers up its sleeve. And if you try and zoom into something like 2 instead, we can go down all sorts of other rabbit holes. Like zooming into 2, not only do you have -2, or we could talk about 2i or stuff like that, we could talk about its type of inverses. 1/2 the square root of 2, 1/2's all the way over there, square root of 2, things like that. And what about the inverse of the square root of 2? Well, the inverse of the square root of 2 can be written a million ways. It's the same as the square root of 1/2. That's a short I made on here. And all these numbers, when you look in with the magnifying glass, you get a sort of never-ending look into what they can mean. So, what else? Another thing that you could zoom in on, and somebody here asked, will the video mention pan-digital numbers? And this video will not mention them as much, although they will be making a secret appearance in the background. Because this video, I don't want to spoil too much about my main channel video that will be coming at some point this week about pan-digital numbers on the main combo class channel. Because that's going to be another like 20-minute deep dive that I get very interesting and right and dense. And they are an example of what we could take a magnifying glass on. In particular, we could take a magnifying glass not only on what pan-digital numbers represent on our base, but the magnifying glass could be sort of a different lens. We could hold the magnifying glass different distances from our face to look at what pan-digital numbers mean in a different base, or a different way of counting. Like how in base 6, a pan-digital number would contain everything from 0 through 5 at least once. Would those have different traits than our pan-digital numbers, or what traits would be the same? What if you go all the way down to binary? Well, if you go down to tally marks, every number is sort of pan-digital. At binary, they aren't all, but which ones are? So, or which ones aren't, is the flip of the question. And when we look at questions related to bases, since we're stuck in a base 10 system, and the episode has to start out by being a little base dependent, because a pan-digital number relates to digits, and digits are a clue you're being dependent on a base sometimes. And we will look at what it means to be pan-digital regardless of the base, in a bigger scale. But sometimes when you are encountering a concept that relates to our base, which a lot of stuff is forced to be, it's like we're already holding up a magnifying glass from a certain distance from our eye, and we want to change how far the magnifying glass is from our eye. So like base 10 is like me looking at you like this. And it's like, well, what happens if I look at it like this? What happens if I look at it like this? Certainly some things change, but what things are the same about the background I'm looking at? Somebody also asked, what would a third axis represent? And if you mean about complex numbers, well, you can describe another direction of rotation, but it turns out you need 2 more variables. It doesn't work to add just 1 more variable. To go upward, you end up needing the next power of 2 amount of letters, such as 1 or I. And so those are quaternions, and I haven't done a video about them yet, but they will be coming at some point. So what else can we take a zoom into to see its interesting patterns? Well, what about an even or an odd number? Now, you might think it's really obvious the patterns that even numbers do. It's obvious that they are the numbers that are whole, but if you divide them by 2, you get another whole number. Odds are the numbers that don't do that. Or maybe if you look at it a little more algebraically, you might say even numbers are the numbers that we can call 2k for some whole number k, and odd numbers are the numbers that can be called 2k plus 1 for some whole number k, or equivalently, you could have said 2k minus 1, if you're including 0 allowed. And which you should include negatives there actually for the k to be allowed, any integer, so you can say negative numbers can have the trait of even or oddness. And when you look at that, you might say, okay, that's the end of the story. We know some simple rules, like if you multiply an even by something, you're going to get another even. If you multiply an odd by something, you're going to get another odd. But what else could we say about the even and odd numbers? Well, if I was looking at the even numbers, and I said, here's my list of even numbers, and I decide I'm going to add up the collective sum of how much has happened so far. Well, here I have 2, then 6, then 12, then 20, then 30. Now, if I analyze these numbers enough, and I thought of different ways they could be divided, because after 2, they are all composite numbers that have some type of divisibility. We'll notice that they have a really clear pattern. This first one, 2, is the area of a 1 by 2 rectangle. 6 is the area of a 2 by 3 rectangle. That's 3 by 4, 4 by 5, 5 by 6. Also, they're just those numbers multiplied, 2 times 3, 3 times 4, and so on. And these are a special type of polygonal number known as a pronic number for some reason in history, or as the term I prefer, sometimes they are called oblong numbers because they're a slightly oblong version of a square. They're a type of almost square in a way, where your dimensions are 1 apart from each other. And if I did a similar thing with the odds, I actually get the straight up square numbers. 1, the total so far is 4, the total so far is 9, the total so far is 16. I get the straight up square numbers. And I also could have found this the other way by looking at the square numbers with the magnifying glass and saying, oh, they're just x times itself. But the differences between each one, the difference is 3 there, the difference is 5 there, the difference is 7 there. If I included 0, which is a square number, then the difference would be 1 there. So if I went that direction from the squares, I'd hit the odds, or if I went that direction from the odds, I'd hit the squares. And so we see, okay, wait, the evens and odd numbers may have some slightly more fundamental relationships to a lot of patterns going on. And if they're connected to squares, are they connected then to everything that squares are connected to? Because squares have a lot of rare ways of describing them. Squares, if we zoom into the squares or zoom into a times table, we'll notice square numbers are the only numbers, and exactly all of them have it, and if and only if you're a square, you will have an odd number of total factors or divisors. If and only if you got an odd number of factors, you're square. So we could even connect the odd numbers to that. We could even say that the odd numbers will define as the numbers that when you take a collective sum of them, you get each of the numbers with an odd number of divisors as your list of collective sums. So with the magnifying glasses, sometimes you even zoom in so far that you hit a different pattern, and then you're like, huh, I could have defined this 2 different ways. I could have said A because of B or B because of A. There's a few different ways to lead to what something even is. And sometimes it's interesting to think of square numbers that way, because we're so hooked on thinking of them as n squared that we sometimes forget or don't know that they also could be called the numbers with an odd number of factors, or the numbers whose prime signature contains only even terms, or the numbers whose the collective sums of the odd numbers. And so there's a lot of ways we could zoom in and redefine the squares. And funny enough, sometimes I'm so interested in connecting those ideas of the squares that I'll be taking some notes and coming back to the squares or something, and I'm like, huh, how can I put this in terms of like the odd numbers or all these other definitions of squares that I've gotten myself used to? And then sometimes I almost forget, oh yeah, it's also n squared. That's another formula for the square. I can just multiply n by itself. So sometimes I lose track of the original definition, and then that comes back to help me. But when you only know that original definition, there are a lot of other ways we could define the square numbers. In fact, just for fun, let's see some of the other ways in which these even numbers, odd numbers, or square numbers would be defined by some friendly fellas who leave comments on the OEIS, Online Encyclopedia of Integer Sequences. Well, if I look at the square numbers, now, of course, they mention that here the definition is that the nth term is n squared. But here they also note it's 0 followed by the partial sums of the odd numbers. and they have a different recursive formula. They also note that it's the sum of two consecutive triangular numbers, which is true. Triangular numbers and square numbers have many relationships that we're going to go into in an episode in early grade -2. Not quite yet. There, in fact, will be probably a few episodes within grade -2 in a little series in that grade about polygonal numbers that do include square numbers. And in fact, when you sort of zoom out from the squares and you look at them compared to other sorts of polygonal numbers like triangular numbers and pentagonal numbers, there is a generalized formula for all of these polygonal numbers that the squares happen to simplify the formula down to n squared, which is what happens when you plug in the fourth polygonal number as the type you're going for in this singular formula when you use 4, because squares are the four-sided polygonal number. And it turns out in a weird way that it's almost like squares just got lucky with this bigger scale polygonal formula, that when you get 4 into that formula, it boils down to n squared. Triangular numbers don't boil down quite as simply. Their formula is n times n plus 1, all divided by 2. Or also could be written as n squared plus n, all over 2. So we also, if we want, in addition to a billion ways of them defining the square numbers, they're probably just going to have a lot to say about the odd numbers too. If we were just seeing what they have to say about those, we can see that these are the continued fraction for that. The smallest, these are the list of the smallest number that is greater than n, being like the nth term we're talking about. Smallest number greater than n, not a multiple of n, but containing it in binary representation. That's interesting. Ooh, I like this term. Haven't come across this term in a while. For n greater than 1, numbers having 2 as an anti-divisor. An anti-divisor, that's a good term. And so many other ways we could define those. Now, if you can get that many interesting facts about the even numbers and odd numbers, and you can even use the relationship of things having an even or odd type status to represent questions about parity, which is like this mathematical even or oddness thing, and to represent a lot of fun games and puzzles. Like a checkerboard has a certain sort of even and oddness with its black and white squares. And if those have so much going on for them, what about threevens and throdds? Multiples of 3 and numbers that aren't a multiple of 3. Well, that's been a question on my mind this past year. How far can I take this magnifying glass on the threevens? How many angles can I look at multiples of 3 and numbers that aren't multiples of 3 under my meta magnifying glass in my brain and notebooks and help from online resources and book resources? How far can I zoom in on the threevens, finding new stuff till I hit a brick wall of what I can find? And the answer is never. Because not only would you never really hit a limit with any topic, but threevens are especially ripe of all sorts of interesting things to find. Threeven numbers, in fact, will, as I've mentioned before, be the main focus of one of the math books I'll be writing. I'll be writing some math books and fiction books over the course of these next few years. Many of them already half finished. And one of the math ones will be almost purely focused on threevens and throdds, as well as a decent amount about evens and odds, because we are with the movement to get threeven in the dictionary, that, like I said, after a few more videos and written texts, I will make a petition which will be backed by proper data as to why threeven should be in the dictionary. And I will also try and make a Wikipedia page for multiple of 3, also known as threeven, because they actually have a Wikipedia page for powers of 3, but not for multiples of 3. And I have way more than enough facts for a Wikipedia page full. So I will be going far down this threeven rabbit hole as grade -1 becomes grade -2, and that continues. And there's a lot to say about them, and we don't want to steal the credit from evens and odds, because those are really cool too. We just want to share a little credit and remove a little credit that our society secretly gives the multiples of 5 by us being in a base 10 system. 5s are the ones who are going to need to lose a little credit to spread it threeven's way. We're not going to take anything from 2. We're going to take it from 5. 5 can handle it. 5 has its pentagons and its golden ratios to do. 6, on the other hand, like these new sunglasses I got, 6 is the first threeven even. And now that is a magnificent number. And some may expect 3 to be the star of the threeven book. But due to evens being quite important as well, the secret star is somewhat multiples of 6. Because when I was looking for interesting patterns that were just particular threeven numbers or traits that ended up having more threeven things than often, they also often have more evenness than often. And so it's typically multiples of 6 that ended up so interesting. There are cases where it was just the threevens, including the non-multiples of 6, that had a certain really cool pattern. But the multiples of 6 were what showed up the most places in my research. So, to whoever said thanks for the live, you are welcome. I do have fun doing this and chatting with you guys. As usual, I go back and forth between having a little topic and checking the chat, so feel free to answer any questions or comments as long as you're not in a rush to get them read. And someone's getting busted. Whenever you hear a siren in the background of one of my videos, it's just there. It's not something I can really fix in editing. So, the birds I like more than the sirens, so I'll say that, but I can handle the sirens. They're kind of funny. I like both of them better than the car alarms. That's the one thing that when it goes off during my videos annoys me a lot. Sirens are just part of the neighborhood. So, let me find my other magnifying glass right here, and we're going to see if this spot right here might be sunny enough in a minute. Maybe we'll actually wait a tiny bit in the stream to try and use the sun's power with the magnifying glass, because the sun's going to spread into the combo class in a minute. It's starting to creep toward the camera. Alright, somewhere in here we got the other magnifying glass. One moment. Maybe it snuck its way somewhere else in the classroom. They're like, oh, here it is. I also got to be careful grabbing around in here. I didn't realize I had left a compass in there. This thing is very easy to stab. But in any case, we got some magnifying glasses. What happens if you do all of them? One moment. Alright, this isn't working. Too many layers of dust. Now this one, tiny as it looks, is good. I was able to burn something with this before at my friend's cabin where it was super sunny. Someone says, by the way, that they want to make sure that I keep writing things down for my thoughts. Do not worry. I'm an obsessive writer. Probably relates to me talking, like liking to talk a lot and talking for like 2 hours straight on some long live streams. when I'm not doing my filming, I am obsessively taking notes about stuff. I write an absurd amount of words each day because I have all these different documents. So I'll always feel the need to write down some new thought very compulsively so that I keep track of it. And that can range from, like, I have a document for combo class, one for song lyrics, one for each of my fiction book projects, one for other mathematical things, one for my threevens book, and so on. Someone asked what's the main benefit of base 6 over base 12. It's a lot neater. The times tables and the fractions are a lot simpler. There are less repeating fractions, and that's partially because 6 gains some good traits by being next to some of the early primes. The earlier the prime, the more fundamental in a way, and the more you want to be using it. And that's part of why base 10 is so absurd, because it's using 2 and 5 and skipping the prime in between. And in base 6 or 12, they both use the 2s and the 3s, and they're both good. They're both far better than base 10. But base 6 not only uses the 2s and the 3s, but 5 is the number 1 less than it, and 7 is the number 1 more than it. And that makes them easier to digest in terms of fractions and times tables as well. So in base 12, 5s and 7s are sloppier, and those are somewhat early primes. So that, like in base 12, something like a fraction like a fifth is pretty messy. And so base 6 ends up just the only downside I have been able to observe is that, you know, some numbers take 1 extra digit worth to write. Some are slightly longer in terms of needing an extra digit or something. But apart from that, which doesn't really matter because we don't write massive numbers or use massive numbers that often, most of the numbers we use would still be in the 1 to 3 digit range. So apart from that, all the other stuff is a bit neater in base 6. So part of that comes from it being in between the next 2 primes after the first 2. But they're both good. I support both, and I can actually predict it being possible that humans at some point go to base 12 before base 6, because could be on the way. I mean, by on the way, it's the wrong direction from base 10, but it could work for people to add the digits before they get comfortable subtracting any and then lose some. I would rather just lose them, though. Plus, a good thing is 6, 7, 8, and 9 all look too much like other stuff. The digits, 6 and 9 look the same but flipped. 8 looks like infinity but sideways. 7 looks like 1 or an L upside down. So we're going to lose some of the lookalikes. So, thank you to everyone saying they would love to get my books, and no, they are not out yet. I will, at some point during this year, be posting written drafts of some bits on my Patreon for some of the tiers. And I'm also going to be upgrading what the tiers get on my Patreon in February. It's just going to be like improvements on stuff, so people who are already signed up don't need to worry about losing anything. It's just going to be like a little clearer about when I credit people's names in videos and stuff like that. And if anything, I'm just trying to get more stuff to all the people supporting on there, because that really helps. So there'll be like rough drafts on there. And then at some point, I will start posting stuff on a website, because I own comboclass.org that I'll start designing at some point. And at some point, I'll put a bunch of stuff there. And at other points, I may look into self-publishing a book. And my goal would be for eventually a lot of my books to be free, because I want people to read them. And I don't want to care about money, because money's one of my least favorite things to think about. So I want my books to be free, but in the intermediate time, there probably will be some books I try and sell too, just so I can have enough money to like hire camera people and editors and stuff. So unfortunately, I need to hustle a little bit to build a team and to spread my ideas as like having to treat it something somewhat like a company or a business, even though I see it as a creative thing. And that's the way to get my ideas to the most amount of people, and maybe someday be able to like start cheap science centers or things like that. But someday, if I ever make a bunch of money from Combo Class, all my books will be free, because my goal is to have people read them. And so remember, if anyone ever wants to help the channels and isn't able to support on something like the Patreon, the other type of support, apart from commenting on videos, of course, helps the algorithm. The other type of support is just spreading the name Demotro or Combo Class wherever. Someday we'll need to get that in a few different journalistic articles, the term Combo Class, and then we can have a Wikipedia page. For now, we also want journalists to include the word threeven casually. So anybody who writes for newspapers or online websites or whatever, sneak the word threeven somewhere in there, because if it's in some articles, we're going to have a far better chance on our petition when it's the right time for me to launch one. So thank you for all the comments. Very nice. I love you all. Very awesome. Like I've already been appreciative about in some recent streams, but I'll give one more appreciative shout out for. Although I knew this channel was going to go big places eventually, because I have big ideas and I'm a hard worker, I didn't realize it was going to be so soon from when I started it that we would be up to 90,000 subscribers on one of the channels. And the main Combo Class channel with the full episodes is a little bit behind. That one's at 24,000, which is still incredibly awesome. But here on my sort of Demotro bonus channel, which is very similar to the Combo Class channel in a less perfectionist way and involves a little more of Demotro thoughts than pure science and math, but it's, of course, a lot of each. This channel has skyrocketed a lot more because of the shorts. Those are what draws a lot of people here. Although it does, it's hard to know when those people just liked one short and like they see me playing around with a weird plant that they liked and they hate math or something. So some of the short subscribers unsubscribe when I do streams like this, but it's still awesome that we're growing at this fast of a rate and slowly solidifying the main channel too, where I know we got like more concrete fans, as well as all the people chatting on the Discord are awesome. And that's just very magnificent and cool. Thank you all so much who have ever left a comment or joined a stream, because you are really helping me try and help the world and just helping me do my cool creative thing. So, someone says to take my stuff to coffee shops to try and grow some legs. I'm going to need to have a team of other people worrying about things like if I ever try and advertise or things like that. I want to dedicate my time to just making content. If anyone does want to try and figure out any ways to help spread the word about Combo Class in a non-annoying way to other people, feel free to reach out to me on my email contact link. I'm always down for people to try and help me spread the word in whatever way. But hopefully I'll be able to dedicate my time to making the videos and doing the research and things like that. Someone asked, does the coat look the same after washing, or do I keep it unwashed? I do wash it relatively frequently. I don't wash it necessarily every week, but I wash it every couple weeks. And so, I try not to get anything that will smell bad or cause certain types of stains that would rot or attract mold or anything. I try and just have it be marker stuff and dirt and stuff, and then I can wash it every couple weeks, and it does not get most of the stuff off. It was washed about a week ago, and it looks like this, so I haven't been in the dirt that much in this week. So pretty much all of this is how it would look after it's washed. And this is just, marker stains. This is burn marks. This is paint. This is a dice that's fused on. So that stuff's not coming out in the wash. Where's the dice? Here it is. I love that little dice that got fused on. Now, there will be a new lab coat in grade -2, which is going to start around the beginning of April. And in grade -2, I will keep this lab coat, and two possible things it'll be useful for are, for one, if I do something dangerous, maybe I'll wear 2 lab coats. And for another thing, if I have some friend or guest over here, I can make them wear the lab coat to protect themselves. So sometimes maybe if I have my new lab coat, but you guys are missing seeing the old lab coat, don't worry. Maybe I'll make my camera guy Carlo wear this whenever we do a fire scene. And just thank you all for all the nice comments. Some people don't understand that the lab coat is actually useful, that there have been plenty of times where either a thorn would have scratched me, something would have burnt me, some mud would have gotten on my clothes underneath this, which I don't really care. I'm not a big fashion guy, but it's better to not have the mud on my other clothes. Or paint would have gotten on my other clothes or stuff like that. This thing is useful. And it's a real lab coat is part of why it's useful. Like it's not like a lab coat Halloween costume. Like it's actually very durable. And I actually like literally had fire coming out of this pocket, and this is all it did. It didn't burn through the coat. Someone said they would love to have me on their podcast as a guest. You can always reach out to me at the contact link, which is I'll say it out loud here, but it's not good to like write it down, otherwise robots see it. But it's either the contact link on my page or it is combouniversity at Gmail, which I'm just saying here because I know that my fans watching the streams, I don't care if you want to reach out to me anyway, not just to say hi, but if you have any way you want to try and help the show or like put me on a podcast or anything like that. No promises that I will be able to get back to all the emails. There are a variety of them and I'm kind of busy, but I am always happy to hear from people. Feel free to try reaching my direction. Someone says they'll get a few guests before me, so I get a threeven number. That'll be a good conversation starter. No worries if I'm not a threeven number. You can find something else cool about the number. I'll accept a square number or hyper 11 or really any perfect power or one of the good primes or some. There's a lot of numbers that I would not mind the number. So let's see. Yeah, and someone's mentioning that someone and their best friend have a company and they're doing it for the creativity of it, but they are able to sustain a company. And I do believe that is one of my main recommendations for anyone who would like the idea of trying to like make a living off their art or to be able to run a company like thing is to not worry about the money for a long time. You need to, that's why, I live with my family right now and I never eat fancy food and stuff like that. So, you can get away with it by working low, having low taste, or by having a really busy side job. I have, a part-time side job, and you really have to focus on it for the creativity. And I wasn't expecting to having even made a cent of money by now. I have made some money off YouTube, not as much as I've spent on it by a long shot. I've spent way more than I've made. I still make barely any, but I didn't expect to have made any money at this point. So that was a nice surprise. And you really got to be in it for wanting people to appreciate the ideas you're putting out into the world. So if you have a slight addiction to getting comments or to making money, working that in a little bit can be good. But more so, you're really just going to want to make a project that even if you just got, 10 comments, but they really liked your video, you'd be like, okay, cool, I did it right. Next time we'll try and get 12 comments that really like my video. And right at the beginning, I started, whoa, there's a bee on my phone right here, honeybee. Landed right on the phone. You guys see the bee? I don't mind it. I like honeybees. They pollinate. It's not going to sting me unless I do anything weird to it. Someone says and the person with the company said their goal is to teach and hopefully through VR, and that if I'm interested to reach out. If they have anything about VR that you think would make an interesting topic for one of my videos, I'm always down to hear about some other like weird technologies and think about incorporating those. One of my friends is into VR, and I haven't tried his headset yet, but he's tried all sorts of stuff with it because he's, into various tech stuff and has just gone down the VR rabbit hole. Um, and I'm not sure what the comment means about the factorial, because the factorial of what type of number? Um, but yeah, if the VR person wants to reach out, they can also email me. I am going to, in grade -2, be having some more other types of guest people featured, hopefully, not just for the sake of someone else talking about the things that I could talk about, but people who either, know a lot about some weird subset of math or science that instead of me, who has a much more scattered, widespread focus and knowledge, someone who knows a lot about a singular type of math or science. I may have appearances from people like that on my channel sometime. And I may also feature people who have any weird type of science technology or any weird types of plants or animals. So someone says, like, a negative numbers factorial. By the normal definition of factorial, you can't, but by an extension to it, known as the gamma function, you can interpret it by taking this function that relies on complex numbers to a degree to fully understand, and seeing how it maps to the factorials and where it would map to at other places. So it's not technically the factorial of -4, but you may see it written that way as long as the author has you under the assumption, or they make it clear that they're really talking about this thing called the gamma function that's a way of extending them. But using that, you can. So someone mentioned a 4D hypercube in VR. That sounds interesting. And of course, by interacting with the 4D hypercube, it's going to mean interacting with its shadow or with a cross section of it or something along those lines, because even those things would be 3D. And I need to plug in my computer. I do have my charger around here, but we're getting low on power. Oops, spilling some Pan Digital numbers. Now, I also at some point may have more guests on my podcast, like some friends of mine or my camera guys. And hopefully at some point we'll have someone here while I'm doing the podcast to run the tech part of it. But I do not know how soon that'll be, because right now, I'm on a very low budget. And so any money I have hiring a camera person or editor, I have to use like super precisely. And I have to try and handle all these streams on my own. But it is fun. Someone wonders, what if we're living in 3D and someone is looking upon us from 4D? And that is possible. It's even possible that we're living in something like the 3D surface of a hypersphere or a hypertorus or hyper something else. All right. After we get this plugged in, what we're going to do is another topic of my magnifying glass being used as, or magnifying glasses. Yeah, what if you made, that'd be a good thing to have. What if you had magnifying glasses that were magnifying, one on each side? Because like glasses usually have two magnifying glasses. That would be really disorienting to wear. I learned with my friend when we were at his cabin using this to try burning stuff, which worked, that if you cover one eye and you hold this up to your eye, you can walk around, and it's really hard and kind of dangerous. Like, it really disorients your perception. And to be honest, it feels like when you're super drunk, which I don't drink anymore. I haven't drank in a really long time. But we called it drunk simulator when you put this on your eye and you try and walk around, because it's super disorienting. But be really careful if you do it, because like I swear, it's more disorienting than you expect, and you'll trip on something. And Quinn said, podcast, what I miss? I was just chatting with a comment who said they wanted me as a guest on a podcast, and I said to reach out and I'll see if I have time. And however, I may call one of my weekly things a podcast at some point. I may, I would like podcasts sometimes, and I like the idea of having some of my ranting be in a podcast form that was also available in just like an audio way. So at some point in the future, I don't know when this will be, I do plan on having one of the weekly shows be less visual and more talking with more subjects. Oh, squirrel. With more subjects planned, and be more something that would be audio listenable and put that places as a podcast and call it that. That would be a little down the line once I have someone else already helping me with the tech side of things and I have more resources and stuff like that. So, yeah, 40 people thinking about the fifth dimension. To whoever mentions those comments, if you're curious about these thoughts about dimensional things, questioning the other dimensions that are above or below them, a good book on that topic is Flatland. Somewhat outdated, but the mathematical parts about dimensions seeing each other still hold super interestingly. So that's a interesting description of if you lived in a flat realm, how it would be like to comprehend a sphere and things like that. Someone asked how I get over perfectionism in creative work, and it's very hard to do that because I have certain ones that I haven't been able to, such as my books. I have more than 10 books that I have more than a book worth of brainstorms written, like more than a book worth of words written on computers and notebooks. So I should have published some books by now because I have literally millions of, well, let me think of, I was going to say words, but like literally probably tens or hundreds of thousands of pages written about books that I want to publish, but I haven't published the books yet. And so some things I am perfectionist about, and I'm still working on that. But sometimes I just snap through a barrier where once you've started posting something, you're kind of like, oh, well, you know, I've already had some videos that I didn't have time to read all the comments on, or some videos where there was some good comments and some bad comments, or videos with no comments, or every sort of thing. And you're sort of like, okay, well, I'm already sort of stuck in this. I might as well keep going with it. So one thing that helps is sort of just breaking the ice for yourself and posting a few things. And then you're like, well, I'm already doing this. So the last few weren't perfect. And now, like, you'll make a mistake in one of them and have to make a correction. Or if it's like my type of thing, there's been like one or two shorts where I've had to, like, afterward write, like, in the pinned comment, like, correction, I wrote one of the numbers wrong. It's supposed to have those digits flipped or something like that. And so once you've done that, then you're like, okay, I guess I'm a little less perfectionist about like the potential of a mess up ruining everything. And apart from that, I don't know, it's hard to say because a little degree of perfectionism does help to try and keep things polished and keep things at a high standard. But you also have to try and do the impossible task of knowing that you are being your worst critic, and that if someone else was watching it, they're going to be looking more for the good aspects and maybe noticing a few of the bad aspects, as opposed to you might take the good aspects for granted and ignore the bad aspects. Another thing that can help with that or with other parts can be to set something aside for a few hours, try and clear your brain for a day, and then come back to it a couple days later and see, maybe you have a fresher view of it and you can notice the things that are good or the things that seem rusty and could use correcting. And I don't know, it's difficult because there are things that I'm still too perfectionist about. And I've actually purposefully divided my channels partially in this way, where I have this channel called Combo Class Bonus or at Demotro, and then I have the one that's called Combo Class or at Combo Class. And the part of why I split them is because I knew I was going to be a little more perfectionist on the Combo Class episodes. And I was even really perfectionist at the beginning, where the first few I was almost like, oh, I don't want to put this out. The audio isn't that good or stuff like that. But I was like, okay, I'm just going to put them out. I'm just going to do it. They're good enough. And I scrapped 1 or 2 episodes and just made the others as good as I could. And I knew I would continue to be a bit more perfectionist on that channel, which I am. So I like to have this channel too, where I'm a little less perfectionist and I can have live streams and bonus videos and stuff like that. So it helped me for my videos to have both options of sort of one that is a little more focused on quality and the other a little more focused on quantity. Not to say I don't try and make these videos high quality. I like to think they're still very high quality, but it's more toward the direction on this channel of let's make sure we get a lot of ideas to the world, and on the other channel a little more of the idea of like, let's make sure we get each idea as good as I could make it. So I don't know, various things. Maybe I'll have more suggestions in the future when I get less perfectionist about writing my books. Someone said hoping to see a squirrel, and they did. Someone says I've taught them more than school. That's an honor. Thank you so much. Although I have various goals with this series, including just creative goals. One of the big goals is to sort of fill in better blanks that I think that school left in people's education, and fill in those blanks in a better way, or even redefine the way schools set up some things in a better way. And so it is quite an honor to know when people have learned from me. Oh, hey, Sage. We got a cat visitor. We got a cat meow. I'm not sure if you saw him or not. Someone wonders if I'm ever going to talk about the metallic means or ratios and perhaps the plastic number. I definitely will. Funny enough, I took a note about those just a night or two ago, because there's something that's common enough that it recurs in a various amount of questions you could ask. Kind of like how the golden ratio has a billion types of question or equation you could form that lead to it as the solution or answer, including one that occurred to me as a kid. I found the number or an approximation of it in middle school by wondering this simple question, which I'll tell that story more detailed later. It came up in an earlier stream. But I was asking another question in an episode that I was being reminded of that question I asked in middle school, which, for a quick synopsis, in middle school I'd wondered which number's square is one more than it. And it turns out that's the golden ratio. But if you ask a similar question, you can get to other ones. If I was asking the question to myself the other day, which number, if the golden ratio is also one more than its reciprocal, which is 1 divided by itself, which numbers are 2 more or 3 more or 4 more than their reciprocal? And by asking that and similar questions, I was led back to realizing that some of the things I was looking for were these things known as the metallic ratios. So that's always fun when you are looking for a pattern yourself and you don't expect to like make a great groundbreaking discovery yourself. You're just looking for what the pattern does, and it leads you back to an old topic that you've already encountered and reminds you, oh yeah, I could kind of, after I connected a few dots, it was like, oh yeah, of course that's the answer to that question. So that'll come up when we do an episode about inverses versus opposites. A number's opposite is one way of describing its negative, and another type of thing you may call that, its additive inverse, you could, and the multiplicative inverse is a number's reciprocal. And so looking at different types of inverse and opposite and traits those have will be a bit for one of our main channel episodes in grade -2. And it's funny, I was just taking some notes about that literally just a day or two ago, and it came up to those metallic ratios. Someone asked if I consider math a science. I think that's somewhat a semantic question, because science, it really depends how you define it. There's, if you're open-ended enough, what isn't science? So I like the idea of math being called a science because it shares so many things in common with science, And there you use the same methods in science and math a lot of the time. There's a lot of patterns in common and overlap with the two. But I do also wonder that if we call math science, what isn't science? You know? So I would say it does have to depend how you define science. With that said, it's good for our culture to consider math a science because our culture respects science more than math for some reason. So let's consider math a science for the time being, because maybe then it'll get better funding and stuff. All right, someone says they'd love to support me. Not sure how you mean support. You can always support me with comments and watching all of the videos. And if you mean support with money, there is a Patreon. So, thank you all for joining me here. The activity that we are going to work on here, wait, let me answer this last one too. Someone said math can also be art. And yeah, I think if you tried to define what is, for example, the overlap between natural science, math, and art, it would be just these Venn diagram like big bulbs. You know, it's a lot of overlap. And it's very subjective. So I don't think there really needs to be a concrete decision on if math is a science, because science is more of a big meta thing where it's like, how much are you using the scientific methods, or how much does something relate to other commonly called science things? So, someone's also wondering if I have any hot takes, rants, or trivia about music or tuning theory. I do, and those are going to be in full episodes. There's going to be a lot of music theory. I am going to do it in one of the music shops I used to work in after hours, because I'm still friends with the boss, and I'm going to have a ton of instruments there, and I'm going to film a bunch of music theory lessons, and then we can go into really weird stuff. Everyone's going to want the weird stuff, like what alternate scales can exist, or what alternate tunings can exist, and things like that. But before we go there, I just have to give you my Demotro theory of what scales and chords and stuff are, because I'm a music teacher. That's like my main day job. I have more music students than math students. And so while I want to step away from that being my day job, just to have time for combo stuff, I'm going to definitely have a lot of music theory over time, and there'll probably be a little series on that in grade -2. They'll take place in the music shop where I used to work, and it will probably start with one about my cheat codes about chords, and which is my Demotro theory, how I teach it, which involves a lot of math. And then we are going to have one about scales, and then we can move on to the weirder, more surreal ones. And in the one about scales, we will get to reuse an animation that this fella named the Magic Fella made for me. That is in an episode I made on the main channel about spiky star shapes. Well, one of the shapes with 12 dots on the outside, where you go either 5 or 7 dots away each time and paint out this spiky thing, that relates to scales. So that shape will return. In fact, to demonstrate the scales, which have a circular, very modular method, I am planning on rebuilding this shattered clock into a musical clock. Now, there is a pretty obvious musical clock that many musicians will know, called the circle of fifths. But I'm actually going to do a slightly more ordered version of musical notes going around here, so that when we demonstrate the fifths, it'll paint out that spiky star shape. And the reason why it works well, one of the things that we will see is the fact that 5 and 7 are co-primed 12 and have no factors in common with it is very fundamental to how we designed our musical language. So let me get a better angle here. I need to be plugged into the charger, unfortunately, which does not have much room. But we're really getting sunny, And as a quick test, let me see if it seems like there's any chance the sun would be able to burn anything. It's hard to tell. No, I don't think we have direct enough. Or maybe. Is that direct enough? All right, guys, just hold on for 1 second while I test this magnifying glass. I'm going to see if it's worth it to try. Yeah, I think this will work. Yeah, this is going to work. Okay, we'll try the magnifying glasses in a minute because the sun's going to get even closer. The magnifying glasses will probably be our last stream activity when it's maximally sunny. Now, we are going to still use the magnifying glasses as an analogy for looking closer at things that you may not have realized you wanted to look closer in. And all of this magnifying glass stuff, the relationships to clue theory, and how I have been realizing they are similar to my philosophies about wanting to examine things on various scales and from various lenses, make me think that we may need to get 1 billion magnifying glasses like we have 1 billion Dyson clocks. But we're going to need them to all be different sizes and shapes. So, thank you all for the comments. What we're going to do now for a little activity of zooming in. Wait, sorry, I got to plug in my phone too if I want to be able to keep reading the comments. Some streams in the future, remember, I may get busier and be less able to read all the comments. You know, as we go on, our streams are getting busier, and I'm also trying to come more prepared to them. And so some of the things like of our weekly streams may be less comment-based in the future. But for now, it's a great time to keep trying to reach out and get answers to any of your questions or thoughts. And in the future, maybe we will split up different days of the week and have like a day where it's like our Q&A stream, and a day where it's like our I talk about math stream, a day where it's our weird shapes on Desmos stream. So I know I've been claiming that I would come out with a stream schedule already, and that's been a little delayed. But I'll see if I'm able to in February. It might be March because I still have like a day job that I'm working on slowly reducing. It might be in March, but maybe I'll try and make it in February, that I have a little more concrete idea of what days I'm streaming. For now, it's a little chaotic, but I will try and be leaving some timestamps and chapters in them afterward for people to flip through to see what topics we covered. So I don't have the chat right now for a minute because my phone's charging over there, just so you guys know, but I'll grab it in a minute. So what we're going to look at for a moment of a magnifying glass back into more depth is we're going to take a little peek at the combo class channel and look at some of the earlier main episodes that I dropped on there. Not watch most of them or any of them probably, but we're going to, you know, we need to get this to come up with me first. We need to say Combo Class is a cool show created by Demotro. It's also a name for this, because it's just a nickname for something when you have two grades that are consecutive. That was unrelated to why I named the show Combo Class, but it does kind of fit because we have a bunch of different ages here watching me. But so it does fit, but that's not why I called it Combo Class. So looking at some of the earlier episodes on here, we're going to see if we have now re-encountered these subjects and learned new ways of what this topic might mean to us. And it related to how when you multiply anything by 9, you have numbers that have a digital root in our base. If you keep adding the digits down to a single number, that's also 9. and that there's a lot of weird ways of playing games with numbers that tricks them into becoming multiples of 9 without you realizing necessarily, and then they have the digit sum trait. And I realized one myself when I was a kid. I forget if I mentioned in the nines episode that one of these tricks I had liked to play with in like middle school and high school, where I realized that if you take any two-digit number, I just did back then, but you can take it further, and you add the digits and subtract that from the original, that you always got a multiple of 9. And I also knew that if you add the digits of a multiple of 9, at least for a two-digit number was all I realized at that age, but now I know it works for any multiple of 9. If you add the digits, you're going to get down to 9 eventually. And so I thought that was a fun trick. Then I forgot about it a while. And then as I was studying more math a few years ago, I saw a different spin on it that was a little different. And I came back to my trick too and tried to find larger versions and did find ways to extend it larger. But one of the even stranger tricks I found, apart from you add the digits and subtract it from the original, is that if you take any number and it has to have, be composed of different types of digits. It can have one multiple times, but it needs different ones. And then you rearrange the digits somehow in any way you want. And then you subtract the bigger or the smaller from the bigger. You always get a multiple of 9. Meaning if you have someone pick any number, rearrange the digits, find the difference, and then keep adding the digits till it's one number, they're guaranteed to get to 9. And 9 has all these weird superpowers, but as I did note in that episode, it's not because 9 is... Here's one thing I didn't note. I said it's not because it's 3 squared. But back then, I wasn't even using the term threeven as much. It was a term I jokingly used once in a while, maybe. But I wasn't on a threeven quest to get it in the dictionary yet. So I didn't mention that 9 is doubly threeven. And because it can be divided by 3 twice and still get a whole number. And yes, doubly threeven does not mean double, doesn't mean even and threeven. You can call that a threeven even. Doubly something means the next power level of that, when you're going doubly even or triply even or things. So doubly threeven means 9. Triply even means 8, for example. And 9, we noted, is b minus 1. And so b minus 1, we saw, got all of these different powers. And there's another way that we've met some interesting powers of b minus 1 in other episodes. Such as, if we go into a modular table, and I had all of my rows of all of my digits that you might have as a digit in our base, like 0 through 9. No 10, because our base 10 or mod 10 is when 10 is back to 0. And you do a multiplication chart with these. You find that the last one does this interesting backwards thing. And if you play other games with your modular charts, you'll notice b minus 1, as well as sometimes b plus 1, have quite interesting properties that we could describe either in modular arithmetic or as patterns in a base with digits, or use 9 as an example for the base we're stuck in, or use 11 for traits that b plus 1 had. And one that I've noted that's fun is that 1111 times 1111, for example, is 1, 2, 3, 4, 3, 2, 1. And that'll work for any number of ones up to b minus 1. If I'm in base 10 right now, I can go with up to 9 ones, and we're just going to write that as squared, multiplying it by itself. This will make a staircase up through 9 and back down. But if I went with 10 ones, it would break the staircase. It would look a little non-symmetrical. And so these work to make not only what I called hyper 11s, but they also, if we went up to b minus 1 worth of them, made a pan-digital staircase. And, well, by pan-digital, I mean this is going toward where our next episode on the main channel is going to include briefly, amidst many other things about them, which is not only do we get a staircase if we go up on a number up to b minus 1 ones squared for a hyper 11, but we also get palindromic numbers from that, which was a topic of a later episode, the perplexing patterns of palindromic numbers. And we also get, if we use exactly b minus 1 ones and no fewer, we get a pan-digital one, where it contains every digit at least once. And in fact, I probably have that written somewhere. That exact one. Yes, I do. Because this comes up briefly in the episode. So I have this exact one written there. Now, that's a tiny portion of the episode. There's a lot of other wild stuff with them. But it is interesting that not only do we see a connection to hyper 11s that I love, the numbers that some would call like a generalized rep unit, although we generalize hyper 11s even further, so they have a flair of their own. And it also relates to b minus 1, which this episode was secretly about. Oh, look, in this bit, I don't know if you can see that with my head there, but here's where the episode was. And if you look at this bit, that it shows when you hover over them, it shows a bit of them. Shows the bit where I spray painted a 9 that is on the side of my house. I'll show it to you sometime. And for now, though, although 9's cool in our base, and it's kind of cool in general as a square number, 6 is an even cooler number. So I'm going with, this is an upside down 6. You know, sometimes we got to pretend we're upside down and have a little different perspective. So I'm going with, I got an upside down 6 spray painted on the side of my house. So what we're going to look at next is on these episodes, some other patterns that we have seen zoomed in that have recurred many times include our threevens, our hyper 11s, and factorials. Factorials began to pop up in some episode, and they've become more and more zoomed in, and this episode's all about them. But they will be a friend of many future episodes, because when you zoom into a factorial, you get permutations, and that's a very possibly applicable to all sorts of math, is the ways you could order things. And when you zoom into 1, as we saw, you get more strange, complex numbers. And one way of zooming into numbers is things like prime signatures. We've seen many ways of zooming into what composite numbers are, where you take the magnifying glass on different ways of recategorizing composite numbers. In this episode, it was their, In this episode, it was their aliquot sum is the different way they can go into families. And in other episodes, it's traits like what their prime signature is. We've also, of course, seen clocks recur many times as we zoom into what clocks can be. And another thing that will be recurring more in the future, that I'm currently in my own research doing the magnifying glass on how this connects to other topics we've covered or will cover, is that idea of co-primeness that I mentioned with the spiky shapes in this spiky shape episode, with the animations of those spiky things that are on the side. Those shapes represent which numbers are co-prime and smaller than a number. And the numbers that are smaller than and co-prime to a number is a really important function that we are going to zoom into a lot more, and it's going to show up a lot of places. And co-prime, remember, means, so like 4 and 9 are co-prime because 4 is made of 2s and 9 is made of 3s. 4 and 6 are not co-prime because they both have a 2 somewhere in them, multiplicatively. That co-prime idea and the idea of for a given number, how many numbers less than it are co-prime to it, shows up a lot more cool places. So, that was just a little peek at some of the zoom-ins on here. I wanted to mention that thing about the 9s episode, but make sure you guys have checked out all these episodes. There's a lot of cool stuff back then that is about a lot of the similar topics we've covered from some other angles that we've approached in the grade, and a lot of fun stuff on there. Now, back to the one called Solar Furnace. Maybe it's almost time to test the magnifying glass. Let me grab my phone to see the comments. And someone's mentioning ways of approximating pi by randomly drawing dots. That's interesting. There's a lot of ways to do that, and at some point we'll have fun with trying approximating as close to pi as we can get from some various different methods. That is a plan someday for an episode I want to do that I think would be fun, is to like pick 5 different ways of calculating pi and see which one then they each get like a time limit. I get like half an hour with each method or something, and we see which one I can get the most amount of accurate digits with. So that'd be fun. Now, what we're going to switch gears to right now is I'm going to unplug, because we got a little battery juice, and put this somewhere where we're going to see more like over here. And I'm going to make us big. No, not that one. This one. And we're going to try and see if... I need a piece of paper or something. If something can get scorched by one of my 3 magnifying glasses by focusing the sun. And if it works, maybe we'll try very safely putting lighter fluid on something to see if it works in conjunction. I want to grab a few pieces of paper of different sorts to see if we have a chance of burning anything. And I will be back very shortly. Let me run and grab those because I also got to go pee. And stay tuned if you want to see a fun science game or test in a moment. For now, enjoy if there's any birds, hopefully. right. So, here's where the sun is in the chaos part of the classroom. And we also have this, which we might as well, since we're pointing this direction, have a bubble. Oh no, it's going at the computer. Where's the big type? Might as well have one bubble for fun, although the wind's playing against me. Maybe the bubble solution that was sitting out here got watered down. I think there was morning dew or something that watered down the solution that was sitting out here. Or maybe it goes bad overnight. Yeah, watered down. So, we're going to try and see if that sun, even though it's a weird angle, is bright enough to focus a little point of light onto the ground or onto something like a piece of paper enough to singe it. Now I have a few pieces of paper here of different sorts, including a newspaper, because some pieces of paper are like laminated almost in a way that makes them less want to burn. However, we're going to try this one to start. Now, of course, don't try this yourself. Anytime you see me do anything with fire or tools in the classroom, not for copying, just to do a test for all of us to be able to observe now, once and for all, how good different sizes of magnifying glass can do this. Although it is a weird angle, but if you see right there, there's a certain spot where we can focus the point pretty small. Our goal is actually to get that white spot that it's making in the center as small as possible. Let me get you a better view here. So this one, it's hard to get the right angle from the sun. Oh, there we go. Look. It's doing it. Isn't that wild? Look. Burnt a hole in it. That's wild. So, let's burn a smiley face. Let's see if we can do that. All right, there's our eyes for our smiley face. It makes an interesting red color on the outside on this purple paper when it singes it. Like singes off part of the blue of the purple. See that? All right, now we're gonna try and make a smile if possible. This smile might take a minute to creep all the way across. I'm surprised how good and quick this is working, even at this weird angle. Now this is the magnifying glass I used back in the day to make something like this work. So next we're gonna need to try the bigger level. Okay, I don't think I'm gonna trace out the whole smile. Sorry, smiley face, we're just doing a few holes for today. So now I need to test the other sizes of magnifying glass and types. I don't know if this one is gonna work at all, this weird shaped one. It makes too much of a weird like multi thing. Yeah, I don't know if this one's gonna do the trick. This one's weird. Yeah, that one maybe not as good. What about the massive one though? What about this big old thing? It's kind of harder to make a small point with it. Oh, whoa. When you make the right small point, it really goes quick, though. Oh, even if it's not that small, it works. Even this little glare is enough to burn holes. That is wild. I need to try and like spell out combo class with this while the camera's still and use that for an intro shot. Isn't that surprising how well that works? So, let's try real quick just seeing what the other textures of paper do, and then we're going to try slightly crazier experiment. Oop. So maybe lined paper isn't as burnable. It seems like the lined paper isn't liking it as much as the other paper. Might have more of like a laminated almost surface. What about the newspaper? Okay, yeah, that one goes quick. The newspaper is definitely the easiest for this. You don't even have to focus it that clearly, and the newspaper goes. That is crazy. I'm like not even trying to focus it that hard. It seems like dangerous to have a magnifying glass around now that I know this. Like if it's pointed the wrong direction, is it just going to start a fire? This is like pretty crazy. I'm gonna have to like actually be careful where I leave the magnifying glass sitting, I guess. What about, can this weird one do it on the newspaper? It's trying. Yeah, it did it. The weird one did it. It's just not as good. What about the small one on the newspaper? Oh yeah, the small one's just as good as the big one. The small one and the big one are just like super efficient at burning. That's pretty wild. Okay. Now, 1 second. On this part, we're going to where is that? Okay. On this part, I may be adding something to this paper to try a little experiment. Do not try this at home. All right. We're going to see if something special can work. And yes, I do have a hose right there. And also, yes, do not try this at home. This is very interesting. Even though I did put lighter fluid on there, that comment about the volatile fluids not burning from it is correct. That is very trippy. Oh, it looks like it's almost going to go. It looked like it almost was going to go. I almost saw a little fire. Unless that's just the smoke going crazy. But I'm not sure if it is enough of like a flame to pick up paper even if it's soaked in lighter fluid, even though it burns holes in it. Well, that's some new science. What if I do it at the edge? Will that make any difference? Yeah, so there is lighter fluid on here. It's even drying off the lighter fluid from the sun heat. It's burning little holes in it and drying off parts of it, but it doesn't want to catch it. That's interesting. Because, like, you see how it's just burning holes in it? Now, definitely do not try this at home. Do I have... Okay, I don't have a lighter. So, I won't show you. We don't need the don't try this at home. But this would go up in a large amount of flame because of the lighter fluid. But it was just burning holes in it. It's wild. So, now we know that the magnifying glass, if I point it the wrong way, could cause a lot of chaos. For example, let's do one or two more examples of what might happen if we singe a particular item. Like, what if I try and burn a 1 as a dot onto one of these blank dice? If I can burn on dots for the faces of blank dice, that would be a pretty good way of making them. Okay, let's see. Where's the angle? The angle's tricky here. Oh, this is because the computer's blocking a little bit of the sun. And don't worry, I'm not going to inhale any of the plastic stuff. I'm not sure if it's enough to singe the top of that. So no effect on the dice, it seems. What if I had accidentally pointed it at a whiteboard? So those things do not have as much of an effect. However, if it was pointed at them for a long time, I bet it would have an effect. Here's one last idea for a test. I had these balloons here from when we were looking at my props in the other stream. Can it pop a balloon? Alright, warning, there's going to be a balloon popping noise in a minute, but the camera won't be super close to it. I'll move the camera. Alright, what's your guesses? Leave a guess on if this will work or not. That's rolling around a lot. How can I get this thing to stay still? Alright, it worked. So I definitely have to be careful if I ever bring the magnifying glass to a birthday party, or I might accidentally pop all the balloons. Okay, this needs to be plugged back in. Let me see if there's anywhere where it's in range of the cord and it's not deathly sunny, causing a wild amount of glare. We are going to wrap up the stream in a minute anyway, though. I have some things I need to do today, but I hope you all have been enjoying our random little magnifying investigations into both the mathematical ways we could look deeper into a topic and into the scientific ways that we could use a magnifying glass. And this isn't charging right. This needs to charge. Okay. Well, let me take a peek through our awesome comments, and we'll see if there's any last chatting subjects before we wrap up today's stream. Okay. It's hard to get an angle where there's not infinite glare. If I'm at a certain spot, I block the glare, so I'll stay right in that spot once I get my phone. I need to get some sort of canopy over here for grade -2. Okay, that's the one spot where I block the glare. I'll try and stay right there for the whole rest of the stream. Okay, so lots of various comments. Someone's wondering why prime numbers are so mysterious, and that's actually one of the good questions in math. If you just think of them as like, I'm crossing off all the multiples of 2 past 2, then crossing off all the multiples of 3 past 3, then 4 is gone, so I skip that. Then I cross off all the multiples of 5 after 5. It's sort of baffling that they're scattered in a still mysterious way. And we have found many patterns, including ones that tell us the approximate amount of primes up to a given size. But we don't know exactly how the primes are distributed in that range, or where they may lie, what types of gaps and constellations occur. And so, very interesting. One of those first episodes I showed on my main channel that I made is called Which Ancient Questions About Prime Numbers Can We Answer? And goes into some of that. And in any case, love you all so much. Right here, the time is about 1:30, so you guys are all in various different places. I expected, since I started this stream at like around noon on a Monday, or 11 a.m. on a Monday, I expected that it was probably going to be people in different time zones, as opposed to people who are at work or school in my time zone. My work's a weird schedule. I have some private students after this, but I was able to do this stream first. So thank you all for joining me. We do now know a new mathematical tool to use in some future videos. That magnifying glass may show up in some fun experiments. We do also, or hopefully you also enjoyed learning about some of these ways we could magnify into things. And it's a good question for you to ponder on your own. If we were able to magnify into all these various traits about something like an even number, an odd number, or a square number, what else could you pick that's something you take for granted as something simple that you could actually magnify in or out of to see more details about? That's always something good to keep in mind. In any case, love you all so much. Catch me in the Discord or subreddit or Patreon, or in our